Hey guys, I am Manoj. Welcome back to another awesome episode from the course C Sharp and .NET for Beginners. Till now, in all the previous episodes, we have used public access modifier while declaring classes and class members. There are total 6 different access modifiers in C Sharp and we are going to discuss about all of them in this episode. We will begin this episode by discussing why access modifiers are needed and then we will have a look at all the access modifiers one by one. After going through this episode, you should have full clarity and full understanding about access modifiers. You should know what they mean and you should be able to choose the best access modifier for your classes, structures and their members. So, let's get started. So let's begin our discussion with why access modifiers are required. In real world, there are many objects. For example, an electric switch is an object, a camera is an object, an airplane is an object, and also a laptop is an object. Every object has its own usage in real world. For example, the purpose of electric switch is to allow or disallow electric current to pass. Every object internally does some processing. It may need some information for that processing. For example, if we switch on the TV, it processes incoming signal and converts it into a picture which is shown on the display. In this case, signal is the information to be processed and television has circuits to process that information. The essential principles which are used in object-oriented programming methodology are inspired from these real-world examples. Object-oriented programming is a programming methodology in which everything is based on concepts of objects. Each object can contain some information or data as well as the processing instruction which are required for processing that data. In object-oriented programming, a computer program basically contains a lot of objects. The objects are created as and when they are needed. Many of those objects interact with one another to produce some meaningful results. C# is object-oriented programming language. C# supports creation of custom types via classes, records, and structures. These custom types serve as a template for creating objects. These custom types allow to define data as well as processing instructions in the form of type members. For example, fields can contain data and properties and methods can contain processing instructions. We already have discussed about how to create classes and objects in one of the previous episodes. Please refer episode 11 if you want to know more about how to create classes and how to define class members. Okay, so if you are following me till now, you know that our main question was why do we need access modifiers? And it is still unanswered. There are many basic principles in object-oriented programming. Two of them are abstraction and encapsulation. Abstraction is basically hiding complex procedures from the consumer. So, abstraction is the idea of defining or understanding something through its essential properties and behaviors. For example, a phone device has a dial pad from which we can dial a number and initiate a call with another device. It also provides a button to end the current ongoing call. So, the essential properties are dial pad, which contains the numbers and some buttons. And the essential behavior is we should be able to initiate the call and we should be able to end the ongoing call. Now, what is encapsulation? Encapsulation is basically a way to achieve abstraction in such a way that the whole implementation reduces to its abstraction. It is basically about making your implementation a black box and only abstraction should be visible to the consumers. So let's take the same example of a phone device. It has a dial pad which is abstracting the functionality. It also contains a lot of other supporting things like it knows the digits you have pressed. It knows how to send signals when the call is initiated. It knows how to process the incoming signal and produce the sound. Now all these things are part of same phone device, but they are hidden from the end user. This is encapsulation. All the functionality is bundled together in such a way that complex parts are hidden and the whole cell phone device can be understood via its abstraction. So the bottom line is abstraction is to describe only essential properties and behavior of a thing. Encapsulation means to implement the thing in such a way that implementation gets reduced to its abstraction. Abstraction and encapsulation are useful concepts to ensure that software system is easy to understand, easy to maintain, and easy to test. In C#, we use interfaces and abstract classes for achieving abstraction. They are helpful to define only essential properties and essential methods which are required for an object. Then how do we achieve encapsulation in C Sharp? For that purpose, we can use access modifiers. When we declare a type, access modifiers help to hide the complex data and processing instructions from the consumers of those type. I hope you are with me so far, and I hope you are clear now about why access modifiers are needed. So let's move on. In this section, we are going to talk about supported access modifiers in C Sharp. In C Sharp, all the types and all the type members have an accessibility level. This level decides whether they can be used from other code in the same assembly or in some other assemblies. Now, assembly is a new word for us. What is an assembly? An assembly is a file with .dll or .exe extension. It is created when we compile the code. Each project contains multiple C# files. When a project is compiled, it gets converted into an assembly. Console application gets compiled into an executable, an assembly with .exe extension. On the other hand, a class library gets compiled into a shared library, an assembly with .dll extension. Now, assembly itself is very big topic, and it is one of the core concepts in .NET. But the information that I have given should be sufficient for you to understand access modifiers. As of today, C# supports 6 different access modifiers, and they are public, private, internal, protected, protected internal, and private protected. In the coming sections, we are going to discuss about these keywords one by one. I am going to explain these concepts via code demonstration. I would suggest you to follow the instructions in the practice coding session to ensure that you get good hold of these concepts. Now, let's open a Visual Studio instance. Let's create a new console application project, and it can be named as console app. After console application is created, you should be able to see that in the Solution Explorer. You should also be able to see a solution file node in the Solution Explorer. Now go to Solution Explorer and then right click on the solution node and select add new project, and this time add a new class library project, and its name should be, let's say, access modifiers.demo.library. It is a demo of access modifiers, and we are creating a class library project for that, and hence the name. Now let's go to console application, expand the dependencies, and then add a project reference to the class library that we have created. So we have our playground ready. We have a main method which can drive the program. We have 2 projects in the solution. And when I build the solution, it will produce 2 assemblies. The console application will produce an assembly with .exe extension, and the class library will produce an assembly with .dll extension. And that's what we need for understanding first 3 modifiers in this list. So let's move on. In this section, we are going to talk about public access modifier. If you have been following all previous episodes, you may know that we have used only public access modifiers in the previous episodes. Let's quickly see how to use this access modifier. Basically, when we define a type, let's say class, it can be defined at 2 different types of places. A type can directly be declared within a namespace, or it can be declared as a nested type within another type. For example, I can declare a class within a namespace, or I can declare a class within another class. I am going to use the word top level types for all the types which are directly declared within a namespace. And when a type is declared within another type, we are going to use the word nested types. So any top level types can use this public access modifier, and any nested type can also use this access modifier. And as far as class members or type members are concerned, any class member can use this access modifier. So it was about who can use this public access modifier. Now let's see who can consume public types and public type members. Public type and public type members can be accessed from within the same type. They can also be accessed from any other type, regardless of whether that type is part of same assembly or not. When a top level type is marked as public, they can be used within same assembly or they can also be used in some other assemblies. So let's add a class person in our class library. Let's now add three properties to this class. An integer value to identify the person instance. And then the remaining two properties are first name and last name. Both of these properties should be of type string and they signify the first name and last name of any person. So our person class is ready now. Now as you can see, when we add a class to a class library, the default access modifier for that class is internal. Let's change it to public. Now also add one method, display, to this class. This method is supposed to display the information on the console. All the properties and all the methods in this person class are public. Now this person class is a top level type because it is declared directly within a namespace and all of its members are also marked as public. Now because the class and the class members are marked as public, they can be accessed from anywhere, from any class and from any assembly. Now just one point to note here, I am going to use the word project and assemblies interchangeably for this discussion, and it is because a project gets converted into an assembly after the compilation. You should understand that projects and assemblies are two different concepts. So as I was saying, all the type members and the type itself are marked as public and that's why they can be accessed from anywhere, from any code, regardless of whether that code is part of same assembly or not. So let's go to console application. Now we have top level statements because I have created a .NET 6 project. But if you are using a lower version of .NET, then you might have a main method. Now this main method is part of a console application project while the person class is part of class library. Now let's see whether we can instantiate the person class in the main method. So in the main method, we can instantiate the class. We will have to include the namespace in order to be able to use this class person. After adding the using statement, we can see that we are able to use the class. So let's instantiate this class and let's set all the public properties. And after that, we can also call the display method. Now if I try to execute this code, the application should build without any errors and I should be able to see the expected output on the console. So the conclusion here is public can be used with top level types and with nested types as well. Also, public keyword can be used with all kinds of type members. One more thing is, when we declare anything as public, it can be used from anywhere in the application, regardless the consuming code is part of same assembly or not. Now, let's move on.
Now in this section, let's talk about the next keyword, private. Like public access modifier, it is also easy to understand what a private modifier means. Now note that we cannot use this keyword with top level types. It can be used only with the nested types and type members. When a type or a type member is marked as private, it is not accessible from outside of its parent. So when I declare a private method inside a class, only that class which has that private method can use it. We cannot use that private method outside the curly brackets which mark beginning and end of that particular class. And similarly, if I define a private nested class, it would be accessible from only within the parent class. So let's move to the code and let's modify our person class. Let's say that I don't want the display method to concatenate the first name and last name. And let's say that I want a separate method, getFullName, to do that job. So let's create a separate method, getFullName. And let's say we mark this new method as private because we don't want getFullName to be accessible from outside this class. So our getFullName method is ready and it is private. Its return type is string and it doesn't need any parameter. Why? It doesn't need parameters because it is instance member, and that's why it can access the properties first name and last name. So let's use these two properties to create the full name and return the full name value. Now because the display method is part of same person class, it can call the getFullName method. Display method is also instance member. So when display is getting executed, .NET Runtime knows the object. That's why for calling another instance member, we don't need to create instance of person class. So let's modify this display method, and instead of concatenating first name and last name here, let's call getFullName. Now let's go to the console application project which contains the main method. Let's use the instance variable of type person, and when I put period after that instance variable, I see a list of suggestions. This feature is called as IntelliSense, and IntelliSense is not showing me getFullName method, although we know that it is part of person class. Now let's say even if forcefully I try to write the method name here, getFullName, it would result in compilation error. The compiler error will say that I cannot use getFullName method because it is marked as private. So the crux of this section is private access modifier can be used with nested types or with any type members. And when we declare a thing as private, it can be used from only within its immediate parent. I hope this clarifies the meaning of private access modifier. Let's move on. Now, in this section, we are going to talk about the access modifier internal. We already have discussed that a project gets compiled into an assembly. An assembly is a compiled version of project. So essentially, project and assembly contains same code. The only difference is project contains C# code files while the assembly contains intermediate code. Now why we are talking about project and assembly again? Because this keyword internal has to do something with it. The access modifier internal can be used with any type, regardless whether the type is a top level type or a nested type. And this keyword can also be used with any kind of type member. And when this internal access modifier is used with any type or any type member, that particular type or that particular type member would be available only for code which is written in the same assembly or the same project. So in our case, we have a person class which is part of a class library. So if I add any internal member to our person class, that new internal member will be available from only within this class library. And it will not be available from the main method or the top level statements. Why? Because main method or the top level statements are part of console application, which is a separate assembly. So let's take an example. In our person class, I can add a private field, let's say birth date, because we want to store only date. Let's say the type of this field is date only. Note that this is a private field, so it cannot be accessed from outside of this class. Now to set this private field, let's add a constructor which takes birth date as parameter. Okay, this part is ready now. Now let's say we want to add a new method getAge. This method should be instance method, and we want this method to be available for only the classes, for only the code which is written in the same assembly. So that's why I will mark this getAge method as internal. This method does not need any input parameter. Why? It is because this method is instance method, so it can access instance members from this class. And the return type of this method should be integer, indicating the age of this person. So within this method, I can calculate the difference between today's date and the birth date of this person, which will give me time span. And from this time span, I can return the years part. It seems our method is ready. Now because we have added a new constructor to this type, the main method must be breaking. Let's go to main method, and here in the constructor we need to pass the birth date. So I will pass some random birth date here. Now just for the sake of this demo, let's see if we can see the internal members of person class in this main method. In the main method, if we use instance variable followed by period, we can see that IntelliSense is not listing the internal members of person class. Can you guess why? It is because person class is declared inside a library, while the main method is part of console application project. As they are not part of same project, main method cannot see the internal members declared in the person class. Now let's go to our class library project and add a new class. Let's say its name is background verifier. As you know, many jobs need background verification, and in most of the cases, there are third-party companies which perform this kind of verification. As an employer who wants to perform the background verification, you just need to pass the person details, and we will try to imitate this background verification flow in this demo. We have added a new class background verifier, and we can add a simple method verify age, which takes a person object as input parameter, and it returns true if the age is greater than 22. Let's assume that this true value indicates that background verification was successful. This method should be public, it should return a boolean value, and its name is verify age. It takes one input parameter of type person. Okay, the method signature is ready. Now in this new method verify age, we can use the instance variable which was passed as input parameter, and let's add a period after that, and we can see the IntelliSense suggestions. This time the suggestions are showing the internal method. Now the important point to note here is private members are still not visible to this class. Let's add a call to our getAge method, and it will return us an integer value, and then we can use ternary operator to check if the age is greater than 22. If it is greater than 22, then the returned value should be true, otherwise the return value should be false. In fact, I can simplify this ternary operation further. We can avoid the ternary operator and we can just say return keyword followed by the condition, because if the condition is true, return statement will anyway return true. And if the condition is false, the return statement will anyway return false. Our method verify age is ready. Now one important point to note is verify age method is part of background verifier class. This background verifier class does not have any instance members, and that's why verify age method is also not using any instance members. So compiler may give us suggestion to mark this method as static, but for the sake of this demo, I will choose to not mark this method as static. Let's keep this method as instance method of this background verifier class. Now let's go to console application and let's open main method. Now let's try to create an instance of background verifier class. In order to call the method verify age on this instance, we will need to pass a person object. We already have a person object in this method, so let's pass that as an input parameter to verify age, and then I can print the outcome of this verification on the console. So we saw that we could not call the internal member on the same object from the main method. And then when we passed the same person object from main method to background verifier class, the background verifier class could call the internal method on the person object. So I hope this demo was useful to understand the fact that we cannot access internal members of a type from outside of its parent assembly. So the bottom line is I can use internal modifier with any type regardless of whether that type is a top level type or a nested type. If you remember, when I added background verifier class, the default access modifier was internal and I changed it to public. And if I change this access modifier back to internal, then I will not be able to use background verifier class from the main method. I hope the purpose of internal keyword is clear now. Let's move on. So till now, we have seen three access modifiers, public, private, and internal. We will need to know a new concept before having a look at three remaining access modifiers, and that concept is inheritance. We already know that there are many core concepts in object-oriented programming methodology, and we already have discussed about abstraction and encapsulation. And like abstraction and encapsulation, inheritance is also one of the core concepts in object-oriented programming. It basically means that we can create a general implementation of an object, and then the general implementation can be inherited to create a new specialized version of that object. And in this process, we don't need to copy the code. And the closest real-world example is a phone device. A phone device can be an Android device, but every Android device manufacturer can have their own app store. Although it is Android-based, it is customized a bit. For example, the phone device manufactured by Samsung may not have same look and feel and may not have the exact same features as the phone device which is manufactured by another Android manufacturer, let's say OnePlus. Similarly, there is another example. every person has some common attributes, like every person has name, birth date, address, etc. And based on profession, every person can also be categorized into different categories, like let's say student or teacher or farmer. Now, depending on the specialized role, they may also have some different responsibilities and they may be performing different actions. For example, a teacher may be spending a lot of time in teaching and researching the topics, while the student may be spending a lot of time in studying the topics. In our demo application, we already have a person class, and let's say that we want to add support for two different types of persons, student and teacher. So let's add two more classes to the class library project. Let's say we don't want to rewrite the code. We already have a person class which has three properties: ID, first name and last name. These two classes can inherit those properties from the person class. The syntax for inheritance is, after the class name, we need to specify a colon operator followed by the base class name, which is person in this case. And here the student is called as derived class while the person is called as a base class. In other words, student class is said to be derived from the person class. Now let's create a constructor in each type to take birth date as parameter. Now because I am in student class, I will try to add that constructor. The important point to note here is student class has not declared any birth date property or field. So how to set that field? Well, we can call the base constructor by using base keyword. For that, after the constructor signature, let's add colon and the base keyword followed by the parameter name birth date within the parenthesis. Now the student constructor can be empty and birth date will still get set properly. Why? Because the student constructor is calling the base constructor, and the base constructor has logic to set the birth date to the private field. Let's derive the teacher class from the person class and add a constructor which takes birth date as parameter, and from here also let's call the base constructor. Now let's go to console application and let's create instances of these two classes. And now if we try to see IntelliSense suggestions on these two instance variables, we can see that IntelliSense suggested ID, first name and last name properties. It is also showing the public methods. So although we have not declared any public properties or any public methods, the classes student and teacher, they have inherited the public properties from the base type person. Now because these three properties and the display method are public, they can be accessed from the derived class regardless of whether the derived class is part of same assembly or not. Now if the derived class is part of same assembly in which the base class is declared, it can also access the internal members of the base class. But the derived class cannot access private members of the base class. Now this was the basic introduction to inheritance in C#. You must have understood how to inherit one class from the other. Let's move on and let's discuss about the next access modifier. Let's now discuss about the protected keyword. We have seen that public members of base type are accessible in derived type, regardless whether both types are part of same assembly or not. We also have seen that internal members of base type are accessible in derived types only if derived type is a part of assembly in which the base type is defined. But internal members are also accessible in other classes which are not derived from the base type. Similarly, we also have seen that private members of the base type are not available for the derived type. So the question is, what if we want to add class members which needs to be available only inside the derived types? And for this requirement, we use protected modifier. When a type member is declared to be protected, it would be available only in the derived types. It would not be available for any other piece of code. So let's go to our person class. Let's add a protected field. Let's say university. This field signifies the university in which the person has studied. Now let's go to student class, and in the student constructor, let's add an input parameter, university. Okay, now we know that base type doesn't have a constructor which accepts two parameters. So we cannot pass the new parameter university to the base constructor. Now let's see if we can access university field inside this student constructor. So let's type this followed by period, and Visual Studio will show us some suggestions. For your information, this keyword holds a reference to the object that is being constructed here. So in the suggestions, we can see all the public members, all the internal members, and the protected members as well from the base type. This means that derived class can set the protected field defined in the base class. Now, although we used a field here to demonstrate the access modifier, this access modifier can be used with any type of class member. So we can declare a protected constructor or a protected method or a protected property if required. Similarly, the protected members will be available inside all the derived types. So I can make the similar modifications in the teacher class. Here in teacher class as well, I can modify the constructor and accept a new input parameter university. And then inside the constructor, I can assign that value to the university field. We have seen how to access protected members from the derived types. But both of these derived classes were part of same assembly in which base class was defined. So now let's create a class in console application project. Let's call it employee class. I will add a constructor which accepts birth date and university name. Let's set university field from the incoming parameter. So even if the derived class is outside the assembly of the base class, it is still able to inherit and access protected field. That means protected field defined in a base type are available in the derived types regardless of whether the derived type is part of same assembly or not. Now let's go to main method. Now in this constructor, we'll have to pass birth date and university. Check the IntelliSense on the instance variable of any type, let's say student, and we can confirm that protected members are not suggested. Similarly, if we try to get the IntelliSense suggestions for person class object, we will not be able to see the protected member. Why? Because main method is not part of derived class. I hope you find these code examples helpful to understand the concept of protected members. Bottom line is, we can use protected modifier with nested types or any type members, and a protected member can be used from within the same class or from within the derived class. Now let's move on. Now let's discuss about protected internal access modifier. This modifier can be used with nested types or type members. This modifier consists of two words, and each individual word is also an access modifier. We already know that protected modifier is used to make sure that the members are available only inside the derived classes. And we already have discussed that internal keyword is used to make sure that the members are available only inside the same assembly in which the type is declared. So can you guess what this combination means? Well, if you guessed that it is union of these two keywords, then you are right. And remember, it is union, not intersection. And that means when a type or a member is marked as protected internal, then that member can be used in any class within the same assembly. But outside that assembly, the protected internal member can be used only inside the derived classes. Now inside the person class, let's add a new protected internal method. Let's say its name is protected internal method. And it doesn't take any parameters, and it also doesn't return any value. Now let's add a simple console.writeLine in this method which prints the method name. Now let's go to student class, and student class is part of same assembly and it is derived from person. So let's try IntelliSense inside the student constructor, and it shows the protected internal method. That means student class can access protected internal method. Similarly, if I go to a background verifier class which is not derived from person, and if I go to the method verify age, let's try the IntelliSense suggestions here to verify if we are able to see the protected internal method. And here also I can still see the method in the suggestions. Why? Because background verifier is part of same assembly in which person class is defined. So within same assembly, protected internal member can be accessed in any code regardless whether the code is in the derived type or not. Now let's go to console application project and let's open the employee class. Now this class is also derived from the person class. Here as well, in the constructor, I can call the protected internal method. But when I go to any other class which is not derived from person type and which is part of console application project, then we will not be able to use protected internal method. So for example, if I go to main method, I will not be able to access the protected internal method on any of the types. So as mentioned earlier, protected internal keyword basically means union of features supported by individual access modifiers, protected and internal. I hope this provides you enough information. Now let's move on. Now let's discuss about the private protected modifier. This modifier is the newest addition to the access modifiers list. Each individual word from this modifier is also an access modifier. Here, the word protected means the members would be accessible from only the derived types. But what does the word private mean? It means that the private protected member is available to only those derived types which are part of same assembly. So let's add a private protected method inside the person class with name, let's say private protected method. It does not take any input parameter and it also doesn't return any value. And let's say this method as well just have a simple console.writeLine statement to print the method name on the console. Now let's go to student class constructor and there we can see that private protected method is accessible. It is listed in the IntelliSense suggestions. It is because student is the derived type and it is also part of the same assembly in which person class is defined. Similarly, if I go to teacher class, I will be able to access this private protected member. But if I go to background verifier class, the Visual Studio IntelliSense suggestions do not include this private protected member. It is because background verifier is not derived from the person type. Now let's go to console application. There also we have created a class employee which is derived from person type. Now if we try the IntelliSense here, the IntelliSense suggestions do not list private protected member. Why? Although employee type is derived from person type, the employee class is not part of same assembly in which person type is declared. And that's why it cannot access private protected members declared in the person class. So the bottom line is private protected members can be accessed from the derived types which are part of same assembly in which its containing type is defined. Now let's move on. Now this section contains some assignment that you can try on your own. So till now we have discussed about all kinds of access modifiers. We have seen the syntax to use them and we also have discussed semantics of those access modifiers. These assignments are to ensure that you get good hold of these concepts. Let's have a look at assignments one by one. The first assignment is create a private field. Now because it is a private, it cannot be accessed by any other piece of code. Now for setting and getting value from that private field, create a public property and then use that public property in the main method. Now let's have a look at second assignment. Second assignment is a bit tricky. Any bank supports savings accounts, current accounts and fixed deposit accounts. And there can be other types of accounts as well. So what we have to do is we have to create classes to represent these accounts. Every class should have two methods, deposit and withdraw. Add general validations in these methods. Some general validations are the amount that you want to deposit should be greater than 0, or let's say the amount that you want to withdraw should also be greater than 0. And if it is a savings account, then the new balance after the withdraw operation should not be negative. And there can be many such general validations that you might be aware of. Try to implement them. And one hint for you, use one base class account. Derive all other account types from this account class. And then use these classes in the main method to ensure that all the code is working. Now the final exercise is bit interesting. You don't need to write the code. You should just try to find some GitHub repositories which contains C# and .NET code. I would suggest you to go to GitHub and try to find repositories where code is written in C#. Then try to go through that code. Also, go through multiple GitHub repositories. The idea is you should be able to understand the access modifiers that they have used for the type members and types. That's it from the assignments section. Now let's move on. Now this is the last section of this episode. In this section, we are going to talk about the things that we have discussed in this episode. We began our discussion with some glossary. I used the word top level types for the types which are directly defined within a namespace. And with the top level types, we can use only two access modifiers, public and internal. With the top level types, if no access modifier is specified, then internal is the default accessibility level of that type. Now public types can be accessed from anywhere in the application, while internal top level types can be accessed from only within the same assembly in which they are defined. We also know that nested types can be defined. So a class can contain another class or struct. In such cases, if we define nested types, they can also have access modifiers. Nested types can use any of the 6 access modifiers. Similarly, type members can also use any of the 6 access modifiers. The default access level for nested types and type members is private. Now let's quickly summarize what does each access modifier means. Public members can be accessed from anywhere in the application. Private modifiers can be accessed only within the same type. Internal members can be accessed only from the same assembly. Protected members can be accessed only from the derived types. Protected internal members is basically union of two modifiers, protected and internal. So protected internal member can be accessed from any code within the same assembly, but they can be accessed from outside the assembly only inside the derived types. Private protected members can be accessed by the types derived from the containing class, but the condition is derived type should be present within the same assembly. Now that was the quick summary of what we have already discussed. Now these are some of my personal thoughts about access modifiers. These can serve as good pointers or good starting points for you to decide appropriate access modifier for any member or any type in your code. Always prefer specifying access modifiers explicitly. Do not rely on defaults. This will increase readability of your code in my opinion. Also, the next suggestion is, in my experience, private and public access modifiers are used more often as compared to other access modifiers. The other modifiers are also used, but their usage is not that frequent. Now, when you are declaring any methods or properties or constructors, you may want to use public access modifier in most of the cases. On the other hand, when you are declaring fields, you may want to use private modifier in most of the cases. This is because fields represent the state of the class, and we do not want state of any class to be modified by a code without any validations. And that's why fields should be private, and properties and methods can have instructions to validate the incoming inputs which modify the states of the class. And that's why it is better to use public access modifier with properties and methods. Another thing, a member should be marked as public only if it can be accessed from anywhere in the application. Generally, when a property or method is marked as public, it should be part of abstraction. It means that method or that property should be essential for the class. For example, when you have a logger class, then log method should be public because logging is the main purpose of logger class. When you are designing your classes and class members, always follow DRY principle. DRY is abbreviation for do not repeat yourself. And there can be a variety of cases in which DRY principle can be applied. So let's say if your public method is very big and it is difficult to understand that method, then that method can be logically divided into smaller method where each method will have single responsibility. In that case, we can use private access modifier for those methods. Also, in some cases, private methods would be required because the same logic is getting called from two different public methods. So instead of repeating the code, it may be better idea to add a private method for the repetitive logic. Generally, it is a common practice to mark anything as public if the member is needed outside the class, but always keep an eye on possible consumers of the member. If the code which will use the concerned member is always going to be part of same assembly, then it is better to use internal modifier rather than public. The remaining access modifiers protected, protected internal and private protected are required only if you are dealing with inheritance. So if you want the members from the base type to be available in the derived types, then you may want to use one of these access modifiers. Remember, you should not write the code for future. When you are writing the code, at that moment, if you are sure that a particular field or property will be required to be accessed from the derived type, then you should mark that field or property or method as protected. If you are not sure, then it is better to use other access modifier. And the other access modifier in that case would be either private or internal, depending on whether you want to allow other classes to access that piece of code or not. Now the final point to note is code evolves over the time. Also, sometimes the requirements change over the time. Hence, whenever you are making any changes to any existing classes, always make sure that the access modifiers of existing members are still making sense. And those are my thoughts about access modifiers. Of course, these are my opinions. If any of these recommendations or suggestions do not fit to your application or your design, then you always have option to deviate from these recommendations. Now let's move on. Alright guys, that's it from this episode. I hope you find this information helpful. Thanks for watching. If you like the contents that I am creating, then please do not forget to hit like and share buttons given below. And most importantly, let YouTube know that you are liking the contents by hitting the subscribe button and by hitting the bell icon so that you keep getting the latest updates from this channel. If you have any feedback or any suggestions, please let me know via comments. Alright guys, see you in the next episode. Namaste.